Okay, class, picking up where we left off at. I said I was not going to draw a graph of this situation labeled asymptotes and inflection point, but I will show it to you here online. Okay, this is a representation of the graph showing the inflection point, the asymptote, and everything else that's required in the axis. So this is a visual representation of that. Okay, now, it says here, how many milligrams of medication are in the bloodstream after 63 minutes? So we would take that equation. We have y is equal to, we have 1,000 divided by, it'll be 1 plus, it'll be 63 over 27 to the negative 1.94 power. Now when we put this in our calculator, it will give us 838.05 milligrams. And we're done with that problem. Okay, now, there are two other problems here. Remember, I told you that there were a few problems that was on this updated version of the final exam review that wasn't in your packet. Here's another problem here, problem number 30. It says, the graph below shows the average student loan debt per borrower in real dollars and adjusted for inflation. What argument does this graph make about student loan debt? Do you think this graph is an appropriate way to show the data? Okay, now this graph is not really complex, but we did cover this in class. We could tell that this is misleading data, especially with the inflation adjusted line here. Yes, it is recognizing that there is some inflation, but it's not taking into other factors into account. This makes this graph look very, very, how should I say? It looks higher than what it actually is. I'm saying as far as the difference in how much each is valued. Because if you look here at the inflation, you notice that the inflation from 1993 to 2014, the values are not that far apart, considering the fact that it's been 21 years. But when you look at the bar graph, it looks significantly far apart according to the bar graph. So this graph here is very misleading because it's having you to think that it is significantly more in comparison dollars, and is actually not. Okay, now, it says the graph below shows the estimated number of nuclear stockpiles in 2005. Do you think this graphic display is an appropriate way to show data? Explain. What could be done to make this data more accurate? Okay, now, if you look here, it says basically that the United States have 10,315. Russia has 7,200 here. Now, this is deployed. This is inactive. But what's interesting is the United States have a larger number than Russia's deployed or inactive, but their slice of the pie is much larger. So that is misleading. Okay, now, it says what could be done to make this data more accurate. Actually, what it could be done is if you added all of these up and then divide by their total number, then you could write them in. You could divide them up in percents that way. You could write them up either as percents, as a table, or you could, if you do a graph, you would have to do the graph where the pieces are cut more representative, because like right here, you notice 10,315 should be a bigger piece of the pie than both of these, and it's not. So you could just draw a graph that's more representative of the numbers that are displayed. And that's basically it. You're just basically showing how these graphs are misleading and what could the solution be. And that's one solution. Okay. And class, just as a reminder, if you still have any questions, please bring your questions to class on Monday over anything that I've covered in this video. And remember, this video only covered where we picked up off at. We picked up on page 11, I do believe, and it was problem 13. So we went there and completed all of the problems in addition to any new problems, and took out any problems that did not belong. So again, if you have any questions or anything like that, please bring it to class on Monday.